Alright, now let's start with stoichiometry practice problems. And the first question on our screen is that there is a compound which contains carbon, hydrogen, oxygen, and we are given the percentage of each atom in the compound. Fine. Then they're asking you to calculate the empirical formula. Now, for these type of questions, there are multiple methods out there. I'll tell you the simplest one, and it just needs three steps. Three steps, and you will be done with the question. Step number one, write the given percentage in grams. 54.54, 54.54 grams. 9.09%, 9.09 grams. 36.37%, 36.37 grams. Why are we doing this? Because if you see, all the three percentages add up to be nearly 100%. That is why. Alright. So step number one done. Step number two is figure out the moles by doing given mass by atomic mass for all of them. Carbon's atomic mass is 12, hydrogen atomic mass is 1, oxygen atomic mass is 16. What do we get from this? We get moles. Moles of carbon are 4.54, hydrogen 9.09, oxygen 2.27. Alright. Now, is this the simplest ratio? Can you write carbon as 4.54, hydrogen as 9.09, and oxygen as 2.27? No, this is not allowed. Atoms cannot be in decimals or fractions. Atoms need to be in whole number ratios. So we are missing a step. Step number three, we divide all the moles with the smallest moles to get the simplest ratio. What do I mean by this? Out of 4.54, 9.09, 2.27. Which one is the smallest one? 2.27. So we divide all of them by 2.27. For carbon, I'm getting a number 2. Hydrogen, I'm getting a number 4. And for oxygen, we are getting a number 1. Now, this should make sense to all of you because we cannot simplify further than 1. If you try to simplify further than 1, it will be converted into decimals, and atoms cannot be written in decimals. So this is what tells me that I have arrived at the empirical formula. So carbon is 2, H is 4, O is 1. Question number 1, empirical formula of compound X is C2H4O1. Now, the second part of this, they're asking you that, alright, you have calculated the empirical formula. Now, we will give you the molecular mass. You tell us the molecular formula. Alright. So, the condition here is that you know the empirical formula and then you know the molecular mass. Molecular formula you have to figure out. Okay. So, I'll just tell you one thing. What you should do is the empirical formula that you have found out, try to find out its mass. I've done the same thing here. C2H4O1. I've tried to find out its mass and the mass is coming out to be 44. And what is this? This is the mass of empirical formula. Now check the mass of molecular formula. It is 88. Rings any bells? Isn't it exactly the double of it? Means if you do empirical formula times 2, you will get the molecular formula. So what is the molecular formula then? C4H8O2. And if you want to cross check, find out its mass, it will again come out to be 88 only. Which means our calculation is correct. I'm repeating this again for all of you. Hear me out carefully. We found out the empirical formula. Then I'm simply asking you, calculate the mass of empirical formula. It is coming out to be 44. Now check the relation between 44 and 88. It is exactly the double. So what do we do? Double the empirical formula, you'll get the molecular formula. Okay. Now we have a titration problem here. Guys, these are called as titration problems. I'll tell you the pattern of these kind of problems. They always give you some acid and an alkali, and they give you the volume of both, and they provide you with the concentration of one of them, and they ask you for the concentration of the other one. This is the exact pattern of titration problems which are asked in IGCSE, GCSE O levels. They will give you volume of both, they will give you concentration of one of them, and they will ask you concentration of the other one. Now let's read the question. 25 centimeter cube of potassium hydroxide is given, along with concentration is given. See, volume is given, concentration is given, which means for the acid they will only give you the volume and they will ask you concentration in the end. Now check the question. Concentration of dilute sulfuric acid. Got it? This is the type of question. Now, how to solve this question? It's very simple. Concentration is equals to moles by volume. So, moles is equals to concentration times volume. We can say this, right? For potassium hydroxide, we know the concentration 2.53 moles per decimeter cube, and we also know the volume, that is 25 centimeter cube. However, there is one issue. The volume is in centimeter cube, concentration is in decimeter cube. So we need to convert centimeter cube to decimeter cube. We can simply remember this: if you divide centimeter cube by 1000, you get the answer in decimeter cube. So 25 centimeter cube will be 0.025 decimeter cube. So concentration is 2.53 and volume will be 0.025. I've written the same thing here for all of you. Check. Concentration 2.53, volume in decimeter cube, that is 0.025. We get the moles, that is 0.063. This is done. Now, the next part, number of moles of H2SO4 needed to neutralize the KOH. Alright. If you try to write the equation KOH plus H2SO4 giving K2SO4 plus H2O. Now if you try to balance this equation, this becomes 2 here. Okay. Now we have to apply the ratio here. Just think about it. 2 molecules of potassium hydroxide are reacting with 1 molecule of H2SO4, right? 2 molecules of potassium hydroxide are reacting with 1 molecule of H2SO4. So if you had 10 molecules of potassium hydroxide, it will be reacting with 5 molecules of H2SO4. The same applies for moles. If you have 20 moles of potassium hydroxide, you will be reacting with 10 moles of H2SO4 because the ratio is 2:1. Basic maths. And written the same thing here in white. Check. Ratio between potassium hydroxide and H2SO4 is 2:1. Means 2 moles in KOH will be reacting with 1 moles of H2SO4. Logical enough? Okay. So in reality, how many moles of KOH do we have? We have 0.063. So just do the half of it. That is 0.032 moles of H2SO4. I hope this makes sense to all of you. If 10 moles of potassium hydroxide are reacting with H2SO4, so H2SO4 will be reacting 5 because the ratio is 2:1, half, 2:1. If you have 10 for KOH, you will have 5 for H2SO4. So if you have 0.063 for KOH, you will have 0.032 for H2SO4. Logical enough? So this gives you the mole here, 0.032. Now again the same question in the end. Concentration of dilute sulfuric acid. See, the formula for concentration is again moles by volume. Volume should be in decimeter cube. So moles we have already calculated, that is 0.032. Volume needs to be in decimeter cube and they always give you in centimeter cube. This is how they try to trick you. So simply divide 28.2 by 1000. It will become 0.0283. And the answer is written here, 1.13 moles per decimeter cube. So this question again is done. Now moving on. So this is a fermentation reaction where glucose breaks down to form ethanol and CO2. This molecule is ethanol. Alright, let's see what they are asking us. In an experiment, 30 grams of glucose was fermented. Fine, got it. Calculate the number of moles. Very simple. We do given mass by molecular mass. What is the given mass here? 30. What is the molecular mass of glucose? You can figure it out on your own. Glucose molecular formula is C6H12O6. So if you do the maths, 6 times 12 plus 12 plus 6 times 16, you will get 180. Alright, I've done the maths already, so I'm just writing it as it is. 30 by 180, that is 0.167. So this gives us the moles here of glucose. Okay. Now come the ratio application part. Calculate the maximum mass of ethanol that could be obtained. Now we again need to check the ratio. See, they're asking you the mass of ethanol. What I recommend all of you to do is, first of all, figure out the moles of ethanol formed. How do you do that? Check the ratio. We check the ratio between glucose and ethanol. It's in front of you. The ratio is 1:2, right? The ratio is 1:2. What does it mean? If 10 molecules of glucose are there, you will have 20 molecules of ethanol. If 5 molecules of glucose are there, you will have 10 molecules of ethanol. This is what a ratio of 1:2 means. Got it? Now, in reality, how many moles of glucose do we have? We have 0.167. So, how many moles will it form? Double of it, because the ratio is 1:2. So, 0.334 moles will be there for ethanol. Okay. So I've written the same thing here. One molecule is giving 2, means 1 moles of glucose yields 2 molecules of ethanol. So 0.67 will yield 0.167 times 2 moles of, this is the mole of ethanol. Got it? Now that we know the moles of ethanol, 0.334, we simply multiply this with the molecular mass of ethanol, which is 46, to get the mass. Now, why did I do this? Here, I'll tell you the formula. Formula says moles is equals to given mass by molecular mass, right? This is what the formula says. You know the moles. Moles are 0.334. Given mass you're trying to find out, molecular mass you already know, that is 46. Okay? So you're ultimately going to multiply anyways. Huh? So just remember this thing, multiply moles with molar mass to get the given mass. So that gives you the answer 15.33 grams here. Okay. Now, the third part, calculate the volume of CO2. For this again, I recommend you to figure out the moles first. And how do you figure out the moles? Check the ratio. The ratio is between glucose and CO2 is 1:2. It's in front of you only. One glucose molecule is giving 2 molecules of CO2 in the product, right? What does it mean? If you have 10 molecules of glucose, that will give you 20 molecules of CO2. If you have 20 molecules of glucose, that will give you 40 molecules of CO2, because the ratio is 1:2. It is getting doubled. Now, how many moles of glucose do we actually have? We have 0.167 moles of glucose, right? So how many moles of CO2 will we get? 0.167 times 2. That again becomes 0.167 times 2, which is 0.334. See, I have written on the bottom left 0.33 moles of CO2. Now we simply need to recall one fact, that 1 mole contains 24 decimeter cube. So 0.33 moles will contain 0.334 times 24 decimeter cube. Right? So that will get you the answer. Okay? Right. So this question is done as well. Now, moving on to the next question. Next question, they have given you some data and they're asking you which contains the same number of molecules. Out of these 4 examples, there are 2 which have the same number of molecules. Even though the values are different, compounds are different, but there are 2 out of these 4 which have the same number of molecules. Now, how do we do these kind of questions? It's very simple. First of all, figure out the moles. Okay? Because we know that 1 mole contains how many molecules? 1 mole contains 6.02 into 10 to the power 23 molecules, right? Now just think about it. If you find out the moles of these 4 and let's say 2 have the same moles, so they will also have the same number of molecules, because 1 mole represents Avogadro number of molecules let's say out of these four, two species get the moles as 2 moles. So they will also have same number of molecules. And how do we find out the moles? Simply do given mass by molecular mass, 2 by 16, 8 by 32. Oxygen is an elemental form, that is O2. So the mass will be 16 times 2, that is 32. Ozone is O3, 16 times 3, that is 48. SO2 molar mass is 64. So if you find out the moles here, we can clearly see that methane has 0.125 moles and SO2 has 0.125 moles. Means if the moles are same, number of molecules will be same as well. So what are the answers? Methane and CO2. Got it? Okay, now in this question, 4.8 grams of calcium is added to 3.6 grams of water. The following reaction occurs. They have given as a reaction, fine. Number of moles of calcium. So for this, we simply need to do given mass by atomic mass of calcium, which I have done here. 4.8 by atomic mass of calcium is 40. So using this, we get 0.12 moles of calcium. Now for H2O, the given mass is 3.6, and what is the molecular mass of H2O? That is 18. So if we do the maths, 3.6 by 18, that gives us 0.2 moles of H2O. Fine. Now, which reagent is in excess? Explain your choice. In case you want to understand this concept completely in detail, I have a separate video for you on my channel. It is named Stoichiometry. It's a 50 minutes video, 50-55 minutes video. It will explain complete stoichiometry to you in detail. For now, I'll be just solving it using the formulas. Now, see. Which reagent is in excess? So, for this, what we do is, we simply use a formula that is moles upon coefficient, and we try to find this value for both the reactants. The reactant having less value of this ratio will be the limiting region. How? Calcium moles are how much? 0.12. So 0.12 by the coefficient. Coefficient of calcium is 1 here only. Alright. H2O, the moles are 0.2, and what is the coefficient? 2. So do 0.2 by 2. Now, this clearly tells us that calcium is larger. So calcium is the excess reagent and H2O is the limiting reagent. Okay. Fine. So calcium is an excess. In this case, they were asking you which reagent is an excess. So calcium is an excess. The reasoning, you can write this in the exam. You will get the marks. Okay. Now calculate the mass of the reagent named in part 2, which remained at the end of the experiment. What they are trying to ask you here is that if you are reacting calcium with H2O, some amount of H2O will be remaining. Some amount of H2O will be remaining because it is an excess, right? So they're asking you that amount. Excess reagent, after the reaction is finished, always some amount of reactant is remaining in excess region. That is why it is named excess. It is in excess. Okay. Now, so how do we do this? We just see this ratio, that this was 0.12 per molecule, and what were the moles per molecule? 0.1. For H2O, the moles were 0.1. If you subtract both of this, you get 0.02, and we simply need to multiply this with 40 to get the remaining mass. See, what I did here is I subtracted 0.12 with 0.1 to get the remaining moles of calcium, which gives us 0.02, and you have to figure out the mass. So multiply with 40. That will give you 0.8. Now again, I'm repeating, this section is one of the complicated ones. We find it difficult to understand what is limiting, what is excess. So for this, I'll again recommend you watch the video which I have on the channel. That will help you gain clarity over this concept mainly. Okay, now next question. They have given us a few reactions and there are multiple questions here. Okay, let's see the reaction first of all. NiCO3 with H2SO4 gives NiSO4 plus CO2 plus H2O. Then you add water to NiSO4, it becomes hydrated. This is hydrated nickel sulfate. And this is the anhydrous form of it. But if you see, the ratio is 1:1 here for all of them, right? Now, this will be very helpful in these questions. They're asking number of moles of nickel carbonate reacted. Okay, if you know that nickel carbonate and on this section you have nickel sulfate. Nickel carbonate moles will be the same as H2SO4 moles because the ratio is 1:1. If the ratio is 1:1, same number of moles will be reacting. So you can directly write 0.08 here. And for H2SO4, the moles are given here already. See. Then mass of nickel carbonate reacted. Now, if you know the moles of a species, you multiply it with its molar mass. Molar mass means molecular mass to get the mass reacted. So 0.08 and I have multiplied it with 190 because mass of 1 mole means the same as molecular mass. Mass of 1 mole is the same as molecular mass, so multiplied it with 190. Then they are asking us mass of unreacted nickel carbonate. See, how much is reacted? 9.52 gram. And how much is given in the question? See, it's written here 12 grams. So how much is remaining? 12 minus 9.52, which gives us 2.48 grams. Okay. Next, the experiment produced 10.4 grams of hydrated nickel sulfate. You have to figure out the maximum moles of nickel sulfate hydrated form that could be formed. Now, this is very simple to understand. I'll just first of all erase the annotations here. So, we have to figure out what are the moles of this. For this, just simply try to understand. These have 0.08 moles. 0.08 moles. Now, if you apply the ratio, this is also 1:1, means nickel sulfate will also have 0.08 moles. Right? Now, the same nickel sulfate is used here. So, this will also have 0.08 moles. Then the ratio between nickel sulfate here and hydrated nickel sulfate here, what is the ratio? 1:1 again. So, this will also have 0.08 moles. The ratio is 1:1 between every one of them, and the product nickel sulfate here is used as a reactant in the second reaction. So again the moles will be same. So for hydrated nickel sulfate the moles will be same as well. Okay. Now they're asking you to find out the maximum mass that could be formed. For this I have told you that the moles you get, multiply it with molar mass of that compound, and let's see if they have given us the molar mass. See, mass of 1 mole of hydrated nickel sulfate is 281. So this is the molecular mass, or you could say molar mass. So I've simply done 0.08 times 281 here to get 22.48 grams. Got it? Now, the last question of this question, last part of this question, they're asking percentage yield. For this, you need to understand the formula. Percentage yield stands for actual yield by theoretical yield. Now, long story short, actual yield is always given in the question. They will always tell you that this much grams of compound is formed. Actual yield, I'm repeating again, it's a very simple point. Actual yield is given in the question. Theoretical yield is the one you find out by stoichiometry. We found out 22.48, and this is what we found out using stoichiometry. So this is the theoretical yield. Actual yield, as I mentioned, it is always given in the question. Let's check. The experiment produced 10.4 grams of hydrated nickel sulfate. So this is the actual yield. Now check this. I've written actual yield by theoretical into 100. Actual is 10.4, theoretical is 22.48 into 100. We get the percentage yield as 46.3%. Alright. Now, moving on to the next question. Now again a similar type of question with less parts. First question is number of moles of NaOH used. Number of moles of NaOH used. So NaOH volume is given here. Along with that, the concentration is given here. So moles is equals to concentration times volume. Concentration is how much? 2.24. Volume is how much? 25. But remember one point, this is in centimeter cube. The concentration is given in decimeter cube. Now in order to convert centimeter cube, divide by 1000 to get decimeter cube. So this will become 0.025. The same that I have done here, you can cross check later. 0.056 are the moles. Now maximum mass of this that can be formed, sodium sulfate hydrated form. Now again, just simply check the ratio. You got the moles of this species here 0.056. What is the ratio between NaOH and Na2SO4? The ratio is 2:1. Means Na2SO4 will have 0.056 by 2 number of moles, that is 0.028. What is this? These are the moles of Na2SO4 that I just found out. Alright. Then the same Na2SO4 is used in the second reaction. So how many moles does it? Is it this? 0.028. Now check the ratio between this Na2SO4 and hydrated Na2SO4.10H2. The ratio is 1:1. So what does it mean? The same moles. It will have 0.028 moles. Alright. Now mass of 1 mole they have given here means they have given you molecular mass. They're asking you the yield. For this, I have simply asked you to do one thing. Multiply the number of moles with the molar mass. You will get the maximum mass produced or the maximum yield. Now, next part, that is our favorite percentage yield question. For this, I told you one simple formula that we have to do actual yield by theoretical yield into 100, and actual yield is always given in question. They will always tell you that this much is formed. Let's find out. Where is it written? 3.86 grams of crystals are formed. Crystals are always in hydrated form. So this is the actual yield they have given you here. And what is the theoretical yield? Theoretical yield is the one that you find out using stoichiometry by applying ratios, which is 9.02 here. So we will just do 3.86 by 9.02 into 100. The percentage yield is 42.8%. Okay. Now, so we are left with only 3 questions. Now, this question looks like a lengthy question, complicated one, but it's one of the easiest ones. Have a look at it. Number of moles of HCl used. They have given you the concentration of HCl here and the volume of HCl here, right? So what do? Concentration times volume. Concentration is in moles per decimeter cube. Volume is in centimeter cube. So we'll have to convert this into decimeter cube, right? So that will be 0.04. The moles are 0.08. First question done. Number of moles of COCl2 formed. Just check the ratio between HCl and COCl2. Is it 1:2 or 2:1? According to me, it is 2:1. 2:1. 2 molecules of HCl are giving 1 molecules of COCl2. Means 10 HCl will give 5 COCl2. 100 HCl will give 50 COCl2. In reality, how many moles of HCl do we have? 0.08. So that will give you 0.04 moles of COCl2, right? Okay. Now the same COCl2, this is used here. So how many moles is it here? 0.04. Now check the ratio between this COCl2 and the hydrated COCl2. 1:1 ratio. So the moles will be same. They're asking you moles of hydrated cobalt chloride. The moles are the same as the ratio is 1:1. Got it? Then they have given you molecular mass of COCl2.6H2O. That is the molecular mass. Maximum yield, what you do? You just simply do moles times molecular mass. to get the maximum mass or the maximum yield. So I've done the same here, 0.04 times 238. 238 is given to us. That will give me 9.52 grams. Alright. Now this section is done. I'll just erase all of this. To show that cobalt carbonate is in excess, number of HCl, number of moles of HCl used. Number of moles of HCl are 0.08 only, and they are also telling you that use the value from above. Means the same answer, 0.08. Then number of moles of cobalt carbonate in 6 grams of cobalt carbonate. So you have to do this by given mass by molecular mass. Given mass they are already telling you here 6 grams, and the mass of 1 mole means molecular mass, so that is 119. So I've done 6 over 119, that is 0.05 moles. Alright. Then explain why cobalt carbonate is in excess. For this, I have told you one formula just for question solving, that use moles by coefficient for both of the reactants. For example, for cobalt carbonate, we have 0.05 moles. And what is the stoichiometric coefficient here? 1. So 0.05 by 1. And for HCl, we have 0.08 moles, but that is for how many molecules? 2 molecules. So divided by 2. Now, which one is larger? Cobalt carbonate is definitely larger. That is why. And I'll tell you one short point. See, in order to find limiting reagent or excess reagent, what we actually do is you compare the number of moles per molecule. I'll write it here. Compare number of moles per molecule. Here you have one molecule occupying 0.05 moles. Here you have two molecules occupying 0.08 moles. Now think about it. How can you compare one molecule with two molecules and say one is stronger, the other one is weak? Do the fair comparison. Compare per molecule. So two molecules of HCl are occupying 0.08. One molecule will be occupying how much? 0.04, right? And here one molecule is already occupying 0.05. Now you can tell which one is in excess. Cobalt carbonate is in excess. That is why cobalt carbonate is the answer here. Got it? Now, this is a titration problem. The same pattern which I told all of you. What they do is they always give you acid, alkali, volume of both will be mentioned, concentration of either one of them will be mentioned, and in the last part they will be asking you tell the concentration of the other species. This is a typical titration calculation problem in our exam pattern. Volume for both will be given, concentration for either one of the will be given. The last part they will always ask you concentration of the remaining one. Now, for the first part they are asking calculate the number of moles of NaOH in this much volume, this much concentration. Basic point. Moles is concentration into volume. So just do 0.4. Volume should be in decimeter cube. So that will be 0.025. The same I have done here. Now use your answer to 1 and the mole ratio in the equation to find out the number of moles of H2C2O4. You have to find the number of moles of H2C2O4. Simply check the ratio between NaOH and H2C2O4. What is it? 2 is to 1. Two molecules of NaOH are reacting with one molecule of H2C2O4. So if you had 10 moles of NaOH, they will be reacting with 5 moles of H2C2O4. In reality, how many moles do we have? We have 0.01 moles. So do the half of it, 0.01 by 2, that is 0.05 moles of H2C2O4. Okay. Now in the last part they are asking you, tell us the concentration of H2C2O4. So concentration is moles upon volume. Moles are 0.005. Volume is given in centimeter cube, so make sure to convert it into dm cube. That will be 0.002. 20 over 1000. This will be 0.02 here, just one zero error to make note of it. Alright, now moving on to the last question and one of the most important ones. Children find these kind of questions to be difficult because in the end they ask you the value of x. What is x? Some of us are like, we are tired of finding x in maths. Why are you giving it to us in chem? But it's fine, it's very easy. See, so they have mentioned insoluble salts are made by precipitation. Fine. This reaction can be used to find x in the formula. Okay. Known mass. Alright. Let's move on to the questions. The number of moles of barium sulfate formed. Have they given us anything regarding barium sulfate? They have given us the mass formed and they have given us the molecular mass as well. The mass of 1 mole. So you simply do 1.398 by 233. That gives you, these are the moles of barium sulfate. Simple question. Number of moles of magnesium sulfate dot XH2O. Now, in this, you will have to assume that this is an aqueous form. So, the ratio will be same. If it is this or if it is magnesium sulfate dot XH2O, the ratio will appear to be the same. So, 1:1 ratio is there. Right? So, whatever moles of barium chloride you have found, the magnesium sulfate will have the same moles. So, 0.06 moles I have written here again. Then mass of 1 mole of MgSO4 dot XH2. Okay? Now, just think about it. Formula is moles is equals to given mass by molecular mass. Mass of 1 mole means molecular mass. So, if to find this, means moles must be given to us. Moles we already know. Moles are 0.006. Do we know the mass formed of hydrated magnesium sulfate? See, mass of hydrated magnesium sulfate is there 1.476. So you put 1.476 here divided by molecular mass. We will get the molecular mass as 246 grams. Are you getting the point? So for magnesium sulfate dot XH2O, the mass we figured out is 246 grams. Now in the end they are going to ask you what is X. Now this is simple maths. Can we find out the mass of this using periodic table? I think this is already given to us anyways. What is the mass of magnesium sulfate? See, mass of 1 mole of magnesium sulfate is already given. Can you find it? Yes? No? It's here. See. Mass of 1 mole of magnesium sulfate is already given. Now, check this out. How simple this question actually is. I'll use, let's say, black marker. So, magnesium sulfate dot XH2O, you already know that this weighs 120 grams plus X times H2O, right? And what is the molecular mass of this total that we found out is 246. So what is the mass of XH2O? XH2O then must be weighing 126. X times H2O weighs 126. Single H2O weighs 18. So you simply do X equals to 126 over 18. That will get you the number 7. That's it. So 126 over 18, that gave us the answer 7. Alright, that's it. These were the most important questions of stoichiometry according to our paper pattern. Now, in case of any doubts, make sure to let me know in the comment section and I'll attach this document in the description as well. Alright, thank you.